Welcome, everyone. I'm so happy that this is the second year now of running this Bevy game development meetup, and the first one of 2025. This is super exciting. We have an amazing round of speakers today, and so without further ado, let's get through the introduction. We're going to have 3 speakers today again. It's already the 8th meetup. I'm super excited about that. Each talk will be around 15 to 20 minutes, plus some time for Q&A. The QR code on the lower left corner is where you can find the Q&A platform. Just drop your questions in there, and at the end of the talk, I will moderate those. The link will also be in the description of the stream, and I will also dump it in the chat later. Just as a reminder, all those presentations are recorded and live streamed now, and I'm going to put up the recordings in a little bit after the meetup, probably next week at some point. So typical code of conduct: be kind, be respectful, be curious, ask a lot of questions. This is where this meetup becomes the most interesting, when you're also involved and ask the speakers questions back. Yeah, and if you have any concerns of any breach of that, please feel free to reach out to me. You know where to find me. A little bit about myself. I'm Stefan. I'm using Rust since 2017. 18 years in game development in my career. You may know me for the creation of Git UI and Live Ask, some full-stack Rust programs. And I recently founded Rust Unit, and this is sponsoring this meetup. And if you want to know more about what Rust Unit is doing, feel free to check out our website. And so here, as a little reminder, this is the QR code to the live QA platform. Please go on there and get involved into the conversation. And now, without further ado, I am going to announce our first speaker. He is actually one of the few that returns already for a second time. And I'm super excited because he's going to talk about a topic that's dear to my heart and probably a lot of others in the Bevy ecosystem, and it's about UI. So please welcome Lorenz, who's going to talk about from pfui to Bevy Hui, make Bevy UI great. So let's give a big hand to Lorenz.
Hey, hello, Stefan. Thanks for having me again on this wonderful meetup. And I welcome everybody in the chat right now to this presentation about UI.
I'm going to give the stage to you. Bye-bye.
Yes, thank you. Okay. Yeah. Let's get started with UI work. Today, I want to give you a brief introduction to a UI crate I'm actively working on and just released, called Bevy Hui, standing for HTML UI. And yeah, it's here to solve some problems I personally have with UI in Bevy currently. So quick background check for me. I'm Lorenz, aka Lomix. I'm somewhat active on the Bevy Discord sometimes. You can find my work on GitHub or on my website, or reach out to me on Twitter, whatever. And without any time wasting, let's start talking about UI. So, for most of you working currently on a game in Bevy or planning to, you will eventually reach the point where you need to create an UI. And for everybody who has done so in the past, they probably know it's not that easy. Usually, it's extremely verbose to describe your UI in Rust code with Bevy UI. It's very tedious and very long to describe simple boxes and relations between boxes and put text in there. And each time you want to check if you're actually having the right result, you have to compile, get to your game state, and then check, notice, oh, damn it, not again, it's 3 pixels off, and repeat. And this becomes tedious very, very fast. And then after you finally have to manage to create something nice, you're thinking about reusing that piece of code. And so you have to refactor your enormous mess. At least that's what usually happens for me when I work with plain Bevy UI. And of course, there are ways to make it a little bit easier. But at the end, for me, the biggest killer to my personal fun is downtime. And whenever I have to wait for compilation just to check if something is 2 pixels to the right or left, that's very annoying, and it kills my curiosity quite fast. So let me introduce you my solution to that problem, and that's Bevy Hui, a way to serialize Bevy UI into HTML, or better, HTML-like syntax that can be hot reloaded into a running Bevy app, and you can immediately see what happens. All the styling in Bevy Hui is based on normal Bevy UI stuff. It's just snake-cased. And now let's start with a quick overview, how the plugin works and how you use it. And then we go deeper into some examples and end it all with a very complicated example how to interact with it. So Bevy Hui is designed to be very, very close to Bevy UI. It does nothing out of the ordinary. It's just a thin wrapper around Bevy UI. So when you're working on the Rust side, there's nothing new. It's just Bevy UI with all its styling and all its functionality. You can hot reload at any time. That's the big selling point. And it offers you a nice way to abstract away your design, your UI design, from the actual logic, which makes it very easy to refactor. I provide a very simple API to wire up the HTML part to your actual logic. And also there are some utilities for animations, transitions, hover effects, and so on that are sometimes very annoying to do it yourself. And without any more waiting, let's get into how you set it up. It's very easy. You just add the plugin like you would with any other plugin, and you spawn an HTML node passing a handle to your template. And that's it. You just spawned a UI. The template itself is tagged as HTML in this case with the HTML extension, but it probably doesn't care about the extension. It's just for your other syntax tools you may have, your prettier formatting or your code highlighting. That's why I prefer to use HTML as the ending. It makes it quite nice to work with. Each template starts with the template tag at the top, followed by the root node, and then you can put in whatever you want. And each of the styling is added as an attribute. As mentioned earlier, they are just the Bevy styles equivalent, but in snake case. And there are a lot of, the value part is very similar to basic CSS, like a padding, for example, can be a single value, 2 values, or 4 values. It's very easy and very short, so you can experiment very fast with it. So, and with just using this example, we spawn our Hello World box. The next step is you probably want to reuse your templates, and that's where components come in. You can register using the HTML component system parameter, register any component under a name of your choice, and then you just can use it as a normal node in your template, and it will be included. Here's the result. You just repeat the same template 4 times. And of course, to make it a little bit more convenient, there's also another plugin, the Hui Autoload plugin, which allows you to add a folder inside your assets folder to be autoloaded under the file name as a component. This is incredibly useful and makes it very, very easy to quickly create components while your game is running and import them into your running state at the same time without compiling. Yes. And of course, there's also error handling. It's not perfect, but if you ever type something bad, you probably get, in most cases, a very context-rich error. You can see that at the bottom. It tells you exactly what you did wrong. But I have to say it's not perfect. If you make tag errors, you're probably, they are probably not so nice. But for attributes, they are quite handy. Okay, let's start with the first example. Let's create a button that we can reuse all over our menus. We start with a simple template, but this time we start with the button node at top. This is just one-to-one a button in Bevy. So, and we're going to add a child node called a text node, and you guessed it, the text node just adds text. And this is the final result. You get a button with some text in it. Of course, it's very boring. We want to add some spice. And this is where some of my additional features come in that are a little bit outside of Bevy UI, but are very, very useful. And these are transition effects. Any attribute can be marked with a hover prefix or a press prefix or an active prefix. More on that later. And then you can add a style. And if that state is active for that button, it automatically changes into it. There's also easing and delay, as well as you can mark each node with an ID, just like you would expect in HTML. These IDs are local to your template. They don't work outside of a single template file, and they help you to reference the entity underneath to another node. For example, this text node watches the btne ID, which is the button on top. And thus, since a text node usually doesn't own an interaction component, you can still hook onto the hover interaction state of the button. And in this case, you see that the text color changes to black. Very useful indeed. Next part, properties. For everybody who has created something with any modern framework in the past, you probably know what properties are. They are the way to make your template add some values you can change when you include them. And they work very easy. You just add on top of your template these property tags, you give it a name and a default value. And in each of your attributes, you can mark them with squirrely brackets, and they will be compiled to the placeholder value or the past values. And there's also something we will talk later, events. They are in the next step. First of all, this is how your button would look now. When you include it, you can just pass these properties as simple attributes, and you are left with a beautiful menu. Okay, maybe not that beautiful, but you get it. You can change the properties, and each of them are unique, even though they are all from the same template. Next up, events. How do we hook our Bevy backend to these nice templates? And for these, we can create called binding functions. These functions are just maps to a Bevy one-shot system. So we make our templating system a string known as a one-shot system. In this case, we register under the name start game a one-shot system, and each of these one-shot systems takes the entity as the first argument. That's the important part. That's the only thing you have to oblige to. The rest are just normal Bevy systems. You can query anything your world gives you. And now with this binding, you can just call it on the onPress event. And for that, we have multiple events in this system. The first one is the onSpawn event. Any node can be marked with an onSpawn event, just a simple attribute. And the onSpawn event, as the name implies, will just call a Bevy function or one-shot system when the node is fully compiled, meaning all the properties are resolved. And then there are the button events. These are unique to the button, or better to say unique to the interaction component. The onPress, onEnter, and onExit button. These are just basic mouse interactions, and you can create a system that hooks onto them. Play a sound, for example. And finally, we have the custom event, the onChange event. This one does nothing by default. It's just for the user to create custom components or widgets that want to tell the rest of your systems that something changed. More to that later. And finally, we have one thing we can work with. These are tags. Sometimes you want to pass information that is not rendered, but is needed for your button to work. For example, you want to set a special kind of difficulty or maybe a different kind of sound, and you want to pass the asset that is played when you enter. Thus, you can just create a tag with your custom name and a value. And then in any of your Bevy systems, you can just query the tag components. You can just query the text components, and it's just inside. It's just a hash map. You can get the difficulty and then do your match, do your things that is required from whatever you need. Now that we have the basics, let's start by creating a simple widget and make use all of these functionality to create a reusable widget. And for that, I'm going to use another plugin I happen to maintain, the Aspirite Ultra plugin. It's just a very simple plugin that lets you load Aspirite binaries. Lets you load animations and sprites, slices, or atlases directly from the Aspirite file binary without compiling them first. So First, we start with a simple Bevy one-shot system. In this case, we are going to need the tags, the commands, and asset solver. We are going to look on the tags for a special tag we call just source. And if that source tag is present and the animation tag is also present, we then simply use the functionality of the Sprite Ultra plugin to spawn a UI animation given the path to the Sprite file and the animation tag presented. In the template, it is very, very simple. All we have to do is pass two properties, the source and the animation. And on our first node, we add the onSpawn, which binds to the attached Sprite one-shot system we just have seen. Together with the two tags, we want to pass the source and the animation. And these are also properties. So when we want to use it now in another API, another template, we are just going to use the Sprite tag, the Sprite component. I have to mention this is inside a component, so you have to register this component or add it into your components folder. And then we're just going to pass the source file. And with that, we are left with a result that looks like this. A simple button with a number and maybe a coin animation, just for the example. So that's the easy part. Now, some widgets require state. For example, a slider. When you have a slider, you of course want to know when the slider has changed. The slider, maybe you want to do something with it. For example, change your volume. And that's where the onChange event comes in. Let's start build a simple slider where the HTML or the styling part is inside a template and the functionality is inside of Bevy. First, we start with the template. The template, or let's define the slider first, I guess. A slider is actually very, very simple. It's just a box, and inside that box, we have a button. The button has an absolute position, and it can move on a fixed axis, but never outside of the container it's in. So between 0 and 100% left, for example. Yeah, we attach our function we are going to discuss in the next step. We call it just the init slider onSpawn effect. So onSpawn function. So this one is called when everything is loaded in, and we add our button with our absolute position. On the init slider function, all we have to do is we get the entity, the container outside and the button inside, and we mark them with two components. In this case, the slider component. This one holds our state, the value, and we start at 0 because the slider starts at 0 for some reason. And then the other entity, which is our button, we mark this with the slider knob component. And this component, just out of convenience, holds inside an entity reference to its owning slider, just so it's easier to resolve and we don't have to walk up the tree each time. So this is somehow, there's some kind of relation like parent or children relation here. Just very, very simplified. So the next part is how do we calculate the dragging of the slider? This is a little bit more complicated and I don't want to go into detail, but the idea is that we query all the mouse events in this case, the mouse motion events, and we query all the sliders and all the active slider knobs, the buttons, which have an interaction. We go through them, filter all the other. First, we iterate all the mouse move events. Then we iterate over all slider knobs. We filter them by pressed, so we only get slider knobs that are currently pressed and the mouse is moving. Then we get the computed style of these nodes, the slider itself, which we can easily access because we passed the entity as part of the slider knob component, and the styling of the knob. Then we do some calculations. I don't gonna include them here, but think of that like this. The button is somewhere in the container. We have to figure out how much percentage it's left to the 0 and then do some calculations and some scaling. If you want to know the exact math, look at the GitHub. It's all open sourced and these slides and examples are there. But out of convenience, I'm not going to go into detail because, yeah, it's just some math. We find the value, the offset, how far the slider currently is. from the left side, and we're going to add the mouse delta in relation to it and make sure it doesn't jump outside of the bounds. And finally, we're going to add the value we just calculated to the slider entity, which holds our state. And now we can trigger our special onChanged event, which does nothing by default, but we tell it here that we are going to trigger on the slider entity, the owning entity. So we just notified everybody else who uses this slider that we have changed. You may look, you may query our values and see for yourself. So, and that's exactly what we are going to do next. We are going to check if our values have changed. And you can see here, we hook the onChanged event on our new slider component, and we call another function, in this case, the update text function. And we also specify a target. Target is another special attribute in this case that can, given an ID, resolves to the entity itself. So when we query the UI target, we don't get the value here, that's here, but we get the entity that is the text. Yeah, very simple. Where are we? Oh, yeah, it's an observer, right? It's an observer in this case. So when the onChanged event is triggered on the update text, we are going to query the slider entity and read its value. And then we are going to get the text that is behind the target entity and change the text inside the text component, and thus the slider updates. And that leaves us with the final result. We have two unique sliders that update the UI at some other place, and you can now easily attach something like change the master volume, change the dialog volume, and you are in full control of the styling part that can still be updated live in the HTML part, and it will resolve without compiling again, and you can easily style your UI. That's it. That's a full example of a complicated widget. There are way more than that. And if you want to create your own or want to go deeper into it, I highly suggest checking out the plugin. I also have a widget plugin which provides some of these functions for you to have something to start off, like a multi-axis slider, text inputs, or some simple drop-downs. And yeah, with these simple API functions, you can basically create anything that any other UI has and still hot reload the styling part. If you want to try it, just do cargo at Bevy Hui, and it's already out, so feel free to try it for yourself. Yeah, that's about it for me. Thank you for listening.
Thank you, Lorenz. Awesome. I still have to get my hands on this myself, but yeah, I think it's exactly like scratching one of those itches, right? That is very hard to keep recompiling and not being able to just edit a script and take a look at the changes. So this is very appreciated. There's a bunch of questions, so let me get quickly started on those. The first one is, so it's technically not HTML, but just XML-like format, correct?
That's correct. It's not HTML, it's not XML, it's somewhere in between, but it looks like HTML. So yeah, there's a cheat sheet. Yeah, I have to mention there's also a big cheat sheet with all the values that you can set on the GitHub. So if you're interested to check out all the attributes available, as I mentioned earlier, it's just snake case, Bevy styling. But if you want to have an overview, there's a cheat sheet.
Nice. Okay. Yeah, do you manually have to add support for all possible node attributes, or is this, is it using some sort of reflection to get that? Like, for example, I guess the recent example with Bevy 15 introducing scrollable like panels and stuff, is that something that only works once you've also added support for it?
I have to add it. There's no way around. It's a custom parser, completely written from scratch. And when I want to hook up it to Bevy functionality, I have to also edit from scratch. It's not that complicated. And I just, this plugin was already available in Bevy 0.14. And when I did the 0.15 update, adding the new UI functionality was very fastly done. It's not that complicated. Just a big match statement at the end.
Yeah, don't tell anyone. Sounds a bit like sounds a bit like Cobweb UI. Are you aware of it? And what are the differences to your crate?
It's similar. It's similar indeed. The main difference, of course, is I wanted to be very close to HTML structure so that I can use tools I already use, like Prettier for formatting or some code syntax highlighting, or even use XML. You can also use XML, and there's also a somewhat broken autocomplete XML. I don't know how these schema files are called. There's a schema file for XML if you want to use that. And you have a little bit of autocomplete, but yeah, it's not truly compatible with XML, so a little bit broken.
But yeah, like Prettier and stuff, they will be able to format it in some sort of sensible way when you use XML for it. Yeah,
they don't.
Yeah. Does your nice UI library work on WebAssembly?
Yes, it's working on WebAssembly. It's working on mobile. It's working for every singular library or target Bevy UI supports, because there is nothing. I didn't do any custom rendering. It's just compiling the syntax, the HTML-like syntax, into normal Bevy UI. There's nothing out of the ordinary there. So every target works.
That is probably their question, because it further states that text input is somewhat tricky and but of course it doesn't really make a difference if you use Bevy UI or Bevy Hui then, because what you end up generating is the same, right? Yeah.
In my widget crate, there's an example for text input, but it's already, as it's not part of the plugin itself. The plugin itself is just the wrapper around Bevy UI with the transition and the API to hook up logic. But there are no pre-built components.
Yeah. Oh yeah, the last question is actually if you've also created an XSD schema for the XML flavor that you built there to probably format it or validate it. I mean,
yeah, it's just the problem is XML doesn't like prefixes. So when you have something like Hava, semicolon or a double point, you will get a huge error. And everything stops working because the namespace syntax in XML is a little bit different. And I couldn't live without that. I didn't want to come up with something special that just works for XML. I'm used to the double point syntax from other front-end libraries, for example.
Gotcha. Okay, well, that's about it in terms of questions. I hope everyone in chat gives you a big hand. This is an amazing crate. It's still on my list to try out and to hopefully improve my life when it comes to building Bevy UI. So very much grateful for you building this.
Thank you for having me.
And thanks for sharing how it works and how it actually looks on this meetup. So thank you, Lorenz. I'm gonna put you off stage, and then we're going to move on to our next speaker. So without much further ado, let's move on to our second speaker tonight. His name is Marco, and he's going to present something very special, which is a game that is very close to getting released on Android, built with Bevy. And so without much further ado, let me put Marco on stage. Hey, Marco, hello. Nice to have you.
Thank you for having me.
Here are your slides. I'm very excited to hear how that journey went. So the stage is yours, Marco.
Great. So hello, everyone. Like Stefan said, I will be talking about how I'm porting my game Crystal Realms to Android with Bevy. I was actually hoping that before this presentation, it would already be released to the Google Play Store, but it's currently in the closed testing phase. But it's gonna be released, if everything goes right, in about a week. And in this presentation, I will also talk a bit about how you can make your own Bevy game work on Android. So first, a little bit about me. So again, my name is Marco. I'm from the Netherlands. I used to do competitive programming. I, for example, won a gold medal at the International Olympiad in Informatics. And besides programming, I also do pixel art. So all of the art you see in the game is also made by me. And as a side job, I'm also a teacher at Harborspace University. So what is Crystal Realms? So Crystal Realms is a 2D sandbox MMO platformer game. The game is planned to be released to Windows, Mac, Linux, iOS, and Android. And instead of explaining exactly what the game is, I think it's easier for me to just quickly show the trailer of the game. Oh. So yeah, that's Crystal Realms. And you might be wondering, why did I decide to build this game in Bevy? And I actually didn't start out making this game in Bevy. I first started programming it in Kotlin using the libgdx game framework. And only in the last year did I rewrite the game from scratch in Bevy. But I did use Rust from the very beginning on the server side of the game. So I chose to use Rust because for my game, safety was very important. Like a glitch could really ruin the economy of the game if it like duplicated items. Another reason that I chose Rust for the server side is because of fearless concurrency. I can have multiple threads without worrying much about race conditions. And also just because I love programming in Rust. I also use Bevy on the server side, but I only include the Bevy ECS crate because, well, I don't need the rest of the game engine. I just like using entity component system for the game's logic. I am using a Bevy a bit different than you would normally use though, because in my game, players can have like multiple worlds. There can be hundreds of worlds online at the same time. So it made more sense for me that each one of these worlds would have its own app, because it's kind of its own separated game world. And instead of each app having like multiple threads like you would normally have in Bevy, the game is running on multiple threads, and in each one of these threads, it is running a single threaded app. So why did I decide to rewrite the client of the game in Rust? There's a few reasons for that. First, just because of performance. On mobile devices, performance is very important, and Kotlin is a bit slower than Rust. The second reason is code reusability. So now I'm able to share some code between the server and the client. The third reason is to be able to use Renet. Before, I was just communicating with TCP sockets because I didn't really find a suitable library for UDP that worked both on Kotlin and Rust. And lastly, for security against hackers and bots, because some players were already like decompiling the game, like the Kotlin version of the game, into Java. And if I rewrite the game in Rust, it's much harder to decompile the game and try to hack the game in some way. Though I, of course, check everything on the server side, so they were not able to do anything very bad. So now let's talk a bit about how you can run your own Bevy game on Android. So there's 3 options to compile your game to Android. The first one is Cargo APK. I think this is a great option for prototyping because it was very easy for me to set up. But the downside is that you cannot publish your game to the Google Play Store because the Google Play Store no longer accepts APK files. You now have to use a Android app bundle. And it's also deprecated. The second option is to use Xbuild, which also allows you to build your project to iOS. It has a helpful xdoctor command, which allows you to find out which dependencies you are missing. But you can't publish your game to the Google Play Store either using Xbuild, or at least out of the box. So the reason for that is that the Google Play Store, like I think half a year ago, they updated their policy that you now need API level 34, and Xbuild was using 33. There is a workaround for it, though, that you can find on their GitHub page in one of their issues, but I haven't tried it out myself yet. And then there's Cargo NDK, which I would recommend you to use in combination with an Android Studio project. So Cargo NDK basically lets you build a Android library from Rust. Doing it this way, you can also add native code. With that, I mean you can add Java or Kotlin Android code, which will allow you to work with some Android libraries. For example, if you want to add in-app purchases to your game. This option also allows you to publish to the Google Play Store. And this is also what is currently being used in the official Bevy mobile example. So what I would actually recommend you to do is just copy the Bevy mobile example and use that as a starting point, or like a similar Bevy like Android starting project. So if you want to migrate your existing Bevy game to mobile, there's only 2 things you really need to add. The first thing is the Bevy main macro to your main function. This will generate like the iOS and Android entry points for your program. And for Android, you need to add this system. Because on Android, if you minimize your Bevy app by default, it doesn't stop playing the audio. So you need to add this system to detect when the app gets minimized and then pause the music of the game. And that's it. Only after doing those 2 changes, you can make your Bevy game run on Android. But of course, if you only did that, you won't be able to interact with your game because you didn't add any code yet to handle the touch input. So to handle the touch input in Bevy, there's 2 options. You can use the touches resource to get the current like fingers on the screen, or you can use the touch input event for like events when, like, for example, a finger moved. But using these like raw touch events is quite hard. It's very complicated with just that to like detect some gestures like double tapping or holding a UI button, for example. So because I wanted to support those gestures, I wrote my own like input manager on top of Bevy to handle like these gestures. So some features that this has is, for example, I kind of combined the mouse input and touch input into like a single thing to so that I don't have to create a separate system for mouse input and touch input. Also, there was not really an easy way to check if a finger was pressing the UI layer or it was pressing something inside of the game world. So I added stuff for that too. And some common gestures like double tapping, holding a UI button, scrolling a UI container, and even I added support where you can like drag and drop things from the UI into the game world. And to this, I also added a way to like focus the keyboard on a specific UI element. This was useful for adding the text inputs. Speaking about keyboard inputs, there's not really a function in Bevy yet to open your virtual keyboard. So what I did is I found this piece of code from like this GitHub page that allowed you to open the virtual keyboard from like Java functions. And I modified it a bit to work with Bevy. So then you get this. But it's not really practical because, for example, here I'm actually typing something in a text input that's underneath the keyboard, so I won't be able to see what I'm typing. And there's many text inputs like that in my game, and I could, of course, add code that will move these text inputs in like the center of the screen, but this would require a lot of refactoring. So what I decided to do instead is to add some code that puts like a text field above the keyboard, so I can actually always see what I'm typing. I actually didn't write this code myself. It was generated by ChatGPT because I don't know much about how to write Android native code. But it seemed to work pretty well after a few minor changes. And I added 3 methods inside of my game activity class, which is like your main Java game class, that I'm then able to call from my Rust code to hide and show this keyboard. And I also added this function get keyboard value to get the current string that is being typed in. And then I added this system to synchronize the Android text field with my in-game text field. So after all that, it looks like this. So now I have I can actually see what I'm typing, and adding this text field also added some other benefits, like being able to copy and paste text, and being able to easily move your cursor around. Then the last thing, adding on-screen controls. So yeah, basically these buttons to move left and right or to jump. So the way I did that is I added this virtual button component, which I can add to like UI buttons. And in this component, I basically say that if a user presses this button, it should correspond to this key on the keyboard. This way, I didn't have to add a special system for the case when the user is on PC or the user is on Android. And then I had this system to do that. So I basically query all the UI elements with a virtual button component. And if that button just got pressed, I will also press that key code. So in case you actually didn't know this, you can actually have a mutable access to the button input resource to programmatically press or release buttons. It's probably not the most like elegant solution, but it worked pretty well for my game. Now, I will talk a bit about some performance improvements, because when you're making like a game for mobile, so it is not really Android specific, but when you're making a game for mobile, it is it's more important to focus on performance improvements, because it's just a slower device. And some things that would not be a performance issue on PC could be a performance issue on mobile. Of course, you should always profile first before you make any performance optimizations. In case you didn't know, there's actually a on the Bevy GitHub, there's actually a page about how you can profile your Bevy app. And one thing that I noticed is that in my game, whenever I had like a lot of UI elements like stacked on top of each other on the screen, it would slow down my game significantly, even though I know that my phone should be able to handle this. So I did a big of digging, and I found that the UI.wgsl shader from Bevy is actually quite complicated, because it also does stuff like drawing rounded corners. And it still does that kind of computation on the GPU, even if you don't have those rounded corners. And since I was not using those rounded corners anywhere in my UI code, I just got rid of them in the shader, and it improved the performance of my game significantly. I also noticed that in cases where my UI would get very complicated, like here I'm for example on my main account where I have like a huge inventory, it would slow down my game a lot, because there were just so many UI elements that the Bevy system for computing the UI layout was taking up all of my CPU power. So the way I fixed this was just I was deleting all of the UI elements that were not on screen. So for the inventory at least. So I made a special way of rendering the inventory slots. So my conclusion, is Bevy ready for Android development? And I think the answer is yes. I mean, I'm about to publish my game to the Google Play Store, but there's still some major issues. Well, not major, just still some small issues with Bevy on Android. So there's still a few small bugs. One of the most annoying ones is that on some Android devices, but not all devices, the UI is constantly flickering. So a bit of an epilepsy warning for this one, but as you can see, this UI node is like flickering, while this regular Bevy sprite is not blinking. But hopefully I might be able to solve it this week, because I finally have access to a device that has this issue. And sometimes when I'm starting up my game, I also get like a random visual glitch the entire duration of my game. And I don't know why this happens. Like, here's a few examples. Here, for example, the game was darker than it normally should be. And here's some very weird ones. This might also be because I'm doing a little bit of custom rendering stuff. But the weird thing is this doesn't happen on PC. It only ever happens on Android. So yeah, that's something to keep in mind. But yeah, that's it. Thank you for listening.
Marco, thank you so much. This is so interesting, and also so typical for mobile development, like especially the glitchy part at the end, and especially on Android with this like huge amount of devices that you have to potentially debug why especially this one type glitches out, right? So it's really good to see more people like trailblazing with Bevy on these platforms to help us all fix those things and get that stuff working, right? So let's go through some of the questions. It's actually quite a lot. So how hard, you mentioned the backend side was written in Rust first, right? So I guess this is going towards that. How hard is it for you to combat hacking issues and denial of service attacks?
That's actually a very interesting question, because I had a denial of service attack, as I told you before. So, well, I'm using Bevy Renet, and Bevy Renet does, at least it says it is able to prevent DDoS attacks. or not prevent, it helps with preventing DDoS attacks. But yeah, I still had a lot of issues with DDoS attacks because they were just draining all of my network usage. So I just switched to a different provider that had a better DDoS protection.
Okay, so basically you let it be fixed on your or DNS provider level or something like that.
Yeah, my server provider. I switched to a different server.
Yeah. Okay. Actually, the next question is actually right at what we already talked about. How hard is it to support this vast Android device landscape? Do you exclude a lot of them? Like, for example, when you show these glitches, like there's obviously also the solution to see in the Play Store, hey, this is used by, I don't know, a fraction of people. So let's just exclude the devices that are completely glitching out, right?
Yeah. Well, for me, it's still hard to say which devices this happens on. Like, I have a list of a few devices where this happens on, but there's I think over 10,000 devices that I am able to support according to Google Play Store. So it's really hard to go through all of them.
Yeah, no, I can imagine. So it's also a big whack-a-mole, right? And especially if you want to really get those devices and your hands on those to be able to reproduce those issues, it's gonna cost a bunch of money as well.
Yeah.
Okay. Your game looks awesome. How hard is it to keep platform A from breaking when changing something on B? How much is it really write once, run everywhere? I think that's the motto of Unity, not Bevy, but yeah, still.
Yeah, it is not the motto of Bevy, yeah. But there's actually there's very few code that is only like platform specific in my game. It's only for a little bit for Android and iOS, mostly to do with in-app purchases and keyboards. But one thing that I think is very important that you should do if you want to support a lot of platform is to get rid of all those system ordering ambiguities, because different CPUs could change the order in which systems run.
Yeah, I think that's a general good idea. I think no matter what cross-platform or not you are planning to do, right? Because that happened to me at least quite sometimes that stuff is biting you then when you're actually implicitly depending on ordering, but you're actually not setting it, right? So this one's interesting. You mentioned double tap, scrolling via touch. That sounds all very generally useful. Are you planning to open source these, or did you already?
I didn't open source these. I'm also not sure how useful it is because I did make some opinionated I added some opinionated things to it. So for example, like Bevy is currently talking about adding stuff for bubbling events, like for input, for example, and I'm not doing that at all. You either press like the button that is the highest layer on your screen.
Yeah, okay. I mean, to be fair, I think alone in this meetup already have seen presentations of like 5 different UI frameworks. So I think opinionated is totally acceptable in this community.
That's true.
But I get your point. But in the end, I think it's still useful to share, and you did share a little bit of that in here, so that's great. The pixel art is amazing, and so is the music. Did you create the music yourself?
No. So the music in the trailer is not even associated with the game itself. But the music that you hear when you download the game, I hired a musician to make.
Oh, nice. Yeah. Okay. Do you use activity or game activity? Any idea what difference it makes?
I think I use game activity, but I have no clue what difference it makes.
Okay. What does your test infrastructure look like? I have no idea if that means backend, front end. I guess let's say everything.
I don't have that many unit tests, to be honest. I have a few unit tests related to item transactions because that is something I really want to get right.
Yeah. Awesome. I just had to smile because the next question just is it's more like a statement than a question. So someone we probably all know, ping me Mockers F on the UI flickering bug fix on Android. I would be very happy to see that. So Francois definitely wants you to reach out. Okay, what else do we have? How many players and installs do you already have? I guess across the board.
I know that the last time I checked, there were about 1,500 registered accounts, but
wow,
I think that was a while ago, so might have been like 2,000 right now. And the game has a Discord server with about 700 users.
Wow, that's impressive. So here goes the test infrastructure, whoever had that question, right? It's like crowdsourced testing. Well, that answers the last question that we had, if there's a Discord server. So I guess it's easiest if you just drop it in the chat later or give me the link and I put it in the description of the recording as well.
It's discord.gg/crystalrealms.
Okay, fair enough. Cool. Marco, thanks again. Everyone in chat's big hand for Marco and Crystal Realms, and I'm expecting a big announcement statement in the Bevy Discord as soon as it finally launched and passed the testing phase.
Yes.
Thanks again for being here, Marco.
Thank you.
Okay, so last but not least, we are approaching the last presentation of our meetup tonight. And our last speaker, Kristoffer, I actually met in Vienna for a Rust conference. And there was actually a surprising amount of Bevy folks there. So it was really cool to be able to recruit our last speaker for today there a few months ago, actually, already. And he's one of the few lucky people working on Bevy in his full-time day job. So I'm very excited to see him share a little bit of the product and how they are using Bevy there. So let's welcome him on stage. Hey, Kristoffer.
Hello.
And
thanks
here
for having me.
are your slides and the infinite. Yeah, there you go.
Yeah.
Okay, Kristoffer, the stage is yours. Thank you so much for being here.
Yeah, thank you. Hi, everyone. I'm going to talk about the product my company makes using Bevy and React. So first, I can introduce myself a bit. My name is Kristoffer. I hang out on GitHub and Discord under the Kristoffer tag. My background is I have a master's in computer science. And as Stefan said, I work with Bevy at least part-time in my day job. I work for a company called Skybox on an esports analytics platform called Skybox Edge, mainly focusing on CS2. I'm also a Bevy contributor. I've been contributing for about a year, mostly reviews, because sometimes when I get home from work, I don't want to do Bevy with all my life. But I have been able to get the PR in here and there. And in my free time, I'm a former Counter-Strike pro player, which is how I ended up working on a CS analytics platform. And now I do climbing and CTF competitions, which is very stereotypical for computer scientists, I guess. So first, let me introduce why I wanted to do this talk. So I think it can be interesting for the community to hear our experience with running Bevy in production. We've been running Bevy now for 2 years, and we've been quite happy with it so far. Then it might also be a signal that Bevy can be used for this kind of thing. I feel like Foresight and stuff already have shown that actually that there are more companies using Bevy right now than for actual games. But maybe a Bevy meetup is sort of preaching to the choir because you probably already know that that is cool. And then by mentioning how we use it, there are some things that could be streamlined. So if anyone else is working in a similar area, I'd be happy to hear about opportunities for collaborating, or if you have problems or solutions to some of the things that I'll talk about. So let me just first show briefly the platform we've made and how we use Bevy in it. This is a screenshot, but I actually want to just show it on my screen. So we have a bunch of stuff on this platform, but the main attraction is sort of a Bevy application in WebAssembly. And this is for Counter-Strike a sort of a 2D top-down replay utility. It allows you to rewind and fast forward through rounds. You can switch to different rounds, filter it in various ways. We use Bevy mainly for sort of the graphical layer, and then we have an API to sort of do React components on top, avoiding some of the UI issues that have been talked about a lot at this meetup and other places. We also have a bunch of other cool features. I'm not here to sell you the product, but just to show that you can do some really cool things. For example, we have a way to overlay multiple rounds together, which can give you some noisy graphics. But if you filter down to like certain players, then you can sort of see their tendencies during some rounds. And then we also have a separate mode, which is called Pattern Finder. This allows you to sort of filter down certain rounds. For those of you who know Counter-Strike, can, for example, filter rounds where a smoke lands both here and here at the same time. And then you can see only those rounds so that you can more easily prepare for games. Yeah, let's go back to some slides. Can I get it full screen? Yeah. So the way we ended with Bevy is somewhat of a long story. So the main developers, me and two other people called Titus and Niklas, shout out to them if they ever watch this, wanted to make this. But we are not really like game programmers. We are hardcore Rust people. So when we needed to decide how do we actually do this in a way that can run in the browser, we tried a few different approaches. We had some experience with Unity, but Unity produces these huge bundles that aren't really gonna be a cohesive fit for a React application. Then we had the idea to try to use SVG. So we, from Rust and WebAssembly, try to just create SVG elements and then programmatically move those around. That's what you can see on the left. This actually, this is one of the very first prototypes that I was able to find going back in our history. It ended up looking quite a bit better than that, but we ended up with a lot of problems. So a lot of the more like every time we wanted to do some extra effect, it would be a horrible SVG mess. And some browsers had extremely poor support for like very nested and updating SVG. So we had to, that was sort of a non-starter. Then we ended up trying WGPU, and this was maybe around 2021, I think. So WGPU was pretty young also at this point. And we actually managed to get a prototype up that worked pretty well. But every time we wanted to add a feature, it was kind of low level. So suddenly people saying, hey, can you add like a gradient here? Then we would say, yep, that'll be a couple of days of work. Whereas, of course, normally in a browser, it would just be like, why can't you draw a line with a gradient? That sounds pretty simple. Around the times we encountered those problems was back when Bevy was starting to get traction. I don't remember the exact version we tried first. I think it might have been Bevy 0.6. But we tested it out and said like, hey, maybe it's also based on WGPU. Maybe it can help us solve some of those problems. And it really did. And we've sort of been using it ever since. So the way we use it is we compile Bevy for WASM using the tool WASM Pack. I'm not completely happy with that because we have to have some workarounds around profiles and other stuff. But for now, that works fine. Then we have a separate React application where we use TypeScript and Vite. We can export some of the types from Bevy and some of our other libraries using another Rust library called pfui. So that we can sort of like have values that move across. We did originally try the web framework U instead of React, but at that point, at least, it was going through a lot of changes, and we ended up with the thing that was mentioned in the first talk that we had to compile in order to see the style changes. And that quite rightly drove us crazy enough to accept to go over to React and TypeScript. I'm personally hopeful that if that maybe even now, but sometimes in the future as well, that the Leptos is good enough that it would actually provide a way to have a full Rust stack to do this. And there's even a Bevy Leptos integration, which would simplify some of the custom stuff we've had to do to make our stuff work. So if anyone has experience with bigger things than that, I would very much love to hear about it. And then as sort of to manage some of the complexity for React, we use the state management library called Zustand, and the Zustand use stores from Zustand to maintain state on the React side, so that Zustand can sort of be the mediator between the Bevy side and the React side. So how do we actually sort of interact between? So the main thing we do is that we have a bunch of shared objects. We register them as resources, and then we place them in resmut or access them with the resmut state parameters. Then we have one unified interface or API that we expose with the WASM bindgen. And then we access these from JavaScript and TypeScript. Then we can sort of mutably change stuff in there, and then that will be picked up by some of the Bevy systems. There is a small complication that if you just spawn a canvas inside React, then when you do hot reloading or the component sort of gets attached or mounted or unmounted in React, then WASM doesn't really like getting reinitialized. So we simply initialize the WASM object first on the very first page load, and then it lives sort of on the window object outside of React and manages its own state. Then it's the main downside of that is that we have to sort of make sure that when we change view and stuff, there might be leftover state from other views. So we have to make sure that we clean up and redraw everything when needed. Input from Bevy, we have a plugin that allows us to send in events. So we have one big event type that are just everything that you can send from the outside. And then that gets broken down into smaller events, like window events or drawing events. We also have a draw tool or other kinds of events. And this plugin just makes sure to get this bigger event type that we can send from the outside and then distribute it to the plugins inside our Bevy application. For output and for all the UI you saw, we simply on the React side poll when needed. So every time we need to redraw or that the state sort of can have changed, we just call some APIs and then we get all the information we need. Yeah, and this is just a small screenshot from the type or one of the functions that draws the bullet lines to show you this the structure. So the shared objects here are called controller state and storage. The controller state is the the struct that controls like, are we currently playing? What time in the round are we currently in? And has a bunch of settings for what we draw and stuff like that. And the storage is where we actually have the game data from the demos that we're replaying. And then we have, of course, a bunch of queries for how we want to draw and some of the textures and materials that we need. In order to run this on other architectures than WebAssembly, because WebAssembly is single-threaded, I guess you could also just use the single-threaded executor if you run it on x86, for example. But an easy way is just to take all of these systems that use the shared thing and then mark these as mutable resources, because then all of them are sort of separate from each other. And then we can just, without fear, lock these at the start of the systems, because we know that another system using these will not be running concurrently. Yeah. Then we have a funny little thing about the difference between our product and normal games in Bevy. So when you have this replay, that's sort of its own state outside of Bevy. And we need to synchronize with Bevy every frame that the replay needs to run. This is a bit annoying, because we have this ECS that's nice for maintaining the state and querying over it, but each frame we sort of have to, at least if we want to do it naively, we have to find out, are there any entities that need to be despawned, are there any that needs to be created, and then update the remaining ones. So when we were originally prototyping this, one of my previous coworkers came up with using the concept from the render world. So we made sort of a transient component that just means that the entity gets cleared at the end of each frame, because then all of our systems don't need to worry about what happened in the previous frame. You just look at the state from the replay and say, oh, I just want to draw that, and then slap a transient thing on it. That allowed us to ship very fast, and surprisingly, after doing some rendering tweaks, performance was actually fine, and we're still using this today. I think in most other game objects, this would immediately kill your performance, but this allowed us to make our product pretty fast. But right now, of course, like with the render world that has just switched to retained rendering in Bevy 0.15, we have later regretted it and are now trying to switch to retained mode. Okay, so what are some of the good parts of using Bevy for this? It's really nice for us, at least, that it's in Rust. I think if you don't mind as much, there are other alternatives like Three.js and Babylon for like JavaScript game engines. But for projects like this, you really do need some kind of game engine structure, and Bevy is the best one I've worked with so far in my career. We ended up needing more game features over time, like adding input handling for touchscreens, needing to draw text, needing to do shader effects. And having this low-level but still very capable game engine allowed us to either use stuff from the engine when we needed it, or pretty easily add stuff ourselves, which is a huge it's very good combination, and a testament to one of the mottos of Bevy, which is that Bevy application developers end up or are also Bevy engine developers. And that's also how I ended up contributing to Bevy, was that I developed some of this and was like, hey, I can also do stuff upstream. We're really happy about the ECS for structure and code and adding new features. Most of the times when I change stuff, I'm like, yeah, I'm pretty sure this works. I basically don't even need to test it. And in general, we haven't had many problems when we deploy new stuff. It's really nice that we can build local binaries. So I can basically have a debug version with gizmos and stuff that I build and run locally on my machine, and that can hot reload assets and stuff. And then when I need to deploy, I just compile it for WebAssembly instead and push that up to production. And then using compile time features also allows for pretty small bundle size. So I've been working pretty hard to get the WASM bundle down in size so that you don't have to wait so long for the replayer to load. And we've managed to get down, I think it was down to 8 or 9 megabytes, because Bevy allows us to strip out like all of the rendering stuff we don't need, all of the inputs we don't need, and stuff like that. There are also some problems we've had. It's been pretty hard to update between Bevy versions, mainly or basically exclusively due to rendering code. Because we started so early with Bevy 0.6, Bevy has gotten a lot of features since then. And I managed to update it until I hit 0.11. But the rendering changes from 11 to 12 were big enough, and some of our custom code for it were difficult enough to migrate, that I haven't managed to find the time to to get any further than that. It's mainly that the rendering code isn't as well, it doesn't have as good a migration guide as the rest of the engine. And of course, it's not an insurmountable problem, but hopefully I'll find the time to do it at some point. The lack of editors of the Bevy editor and tooling sometimes makes debugging hard. The sort of typical problem that you run into is that you try to spawn some stuff and you make some systems to interact with it, and then nothing happens on the screen. And then you have to figure out, why did nothing happen? Was it because I missed a component on one of my entities? Was it because my system queried for the wrong thing? Is it because my rendering stuff is broken? Did I have the wrong coordinates and stuff like that? And even just a tiny bit amount of better tooling would make seeing what's going wrong easier, I think. But hopefully that's coming. Our transient plugin made debugging even harder, because for normal Bevy applications, you can just use Bevy System Inspector to at least get some overview of what's going on. But of course, if you delete the entities in the main world every frame, then you're just going to see a mess if you try to look at what's going on. Then we had surprisingly big problems with resizing. So when you resize in the browser, and we have this canvas that we try to fill a dynamic amount of the screen, you have to make sure that the canvas is the same size as Bevy thinks the screen is. But these can vary independently. And what we ended up having to do was have a resize observer in the React code that can look for every change in the canvas size, and then do an event to Bevy and say, hey, the screen size changed, can you please like resize your window? And this still doesn't even work in the browser tooling that allows you to test for mobile devices, for example. If you try to do that, then it will just go into an infinite resize loop that I haven't figured out how to fix. And the UI is very verbose in Bevy, as we also know. Luckily, we managed to avoid most of that by just not doing any UI and just using React for that instead. Then things that I think could be improved either in Bevy or in our own product. It would be really interesting to do cache busting with the Bevy's asset system. It might be, I haven't researched it, it might be a trivial thing that you could hook up if you have a good idea, or it might be something where the asset system needs to be improved. But currently, when we deploy, most of our bundler can sort of cache bust most of our stuff, but Bevy's assets aren't included in that. So sometimes if we change something, then the old version will still be served by our front end. It would be interesting to have a community plugin for some of the React interoperability. We do have some nice features on top of the thing we did. For example, we have a crash detection system where React sort of monitors the Bevy application inside and sees if it's crashing, and then it can serve up an error message and say, hey, something has gone wrong, please try reloading the page. If there's any interest in that, then I'll be happy to talk. Maybe we can end up making a crate or a package for it. Then I'm looking forward to Bevy CLI for prototyping and bundling. as I said in the beginning, I'm a bit tired about Wessenpack, and I think Bevy Hui will very soon be better than Wessenpack in every way. So I'm looking forward to being able to use it. The main problem here is that Bevy CLI right now, as far as I'm aware, only supports 0.15. So I need to update first before I can try it out. It would be nice with some 2D rendering performance improvements. When I draw like all of these rounds on top of each other in the multi-round mode, it does lag a bit. Normally, React is actually by far the biggest performance bottleneck we've had. But if you draw enough 2D things, then you do end up with performance problems. And then I'm really looking forward to the thing we all do, which is the construct trade and reactivity and BSN, because I think that could really simplify some of the stuff that we originally used the transient stuff for. And with that, my talk is done. So yeah, happy to take any questions.
Thank you so much, Kristoffer. Really interesting product and stack, of course. Yeah, there's a bunch of questions, so let's dive right in. You mentioned Unity bundle size. I mean, you mentioned that you got Bevy down to what's something like 7, but how does that actually compare to something that you prototyped or researched with Unity?
So it's a bit hard to compare because before we did the 2D stuff, we actually had a similar product going, but for 3D. You can find it on, it's not really maintained anymore, but you can find it on Steam called Skybox 3D. So when we tested that, it was primarily loading 3D assets and stuff. And that, of course, when you tried building that for the browser, it became huge. But frankly, when we wanted it more integrated into the platform and being able to live with the React life cycles, I don't think how that would have quite worked because Unity likes to just be in an iframe and then it does its things. But I don't have any concrete size numbers for Unity.
But yeah, interesting. Sounds like a plan. Sounds like the plan already before was to use Rust. How come? And is that used in other places in the company? Because I think you mentioned that you were huge Rust fans.
Yeah. So the way the thing that introduced Rust was that we did our own library for parsing Counter-Strike demo files, and basically we have sort of a data analysis framework that we do stats and get this game data from, and that was all written in Rust. And since we were Rust programmers working on that as well, and we had all of our types and all of this stuff in Rust already, then being able to reuse that and staying in one language was really appealing to us. So yeah, that was the main reason. Yeah,
interesting. I mean, that's how it often starts. If you want to parse something super fast.
Yeah, exactly.
Okay, and I mean, you kind of touched on that already a little bit, but maybe you can give us a little bit more examples on the performance side and limitations that you might have come across on the web with Bevy. You mentioned only 2D rendering here. Is there do you remember some specific improvements that you had to make?
I think mainly it was when we did the transient thing where we delete stuff from the main world every frame. If you do that and just use the basic rendering abstractions, then you might end up sort of sending stuff to the GPU each frame, and that ended up being a bit too slow. So we ended up having to do some of the mid-level render code to sort of mitigate that. But apart from
because it thinks that it's a different mesh or something every frame, or what?
Yeah, something like that. And we also we wanted to have we have some custom shaders where we get the player data about what health do the players have and stuff that we use to draw some of these effects. And then we had to sort of update that every frame. So we have some custom code for that. But apart from some of those things and us being we weren't super rendering people, we sort of learned as we went. But apart from that, I don't think we've had any real performance problems. Apart from normally you would think drawing a couple of thousand things in 2D should be pretty easy for modern graphics cards. but you do start to hit a slowdown if you draw enough in Bevy. I know it's something that the Ice Sentry has wanted to improve on for a while. So hopefully that will improve at some point. But again, for our application, if you get up to a point where you have 1,000 things on the screen, you can't really see what's going on anyway. So the solution is just to filter it down to a data set that you can actually work with, and then the performance is fine for us.
Yeah. Why use a mutex and not a queue at controller state? I guess that's the source that you showed.
So I don't know how. So what we use for controller state for is like that's what controls like the state of the replay. Like it's 10 seconds into the round. It's currently playing back or paused. And a bunch of other things, and that's just the kind of state where you don't want to do that with events where you have an event where you say now you start playing, now you stop playing. It's just an extra layer of indirection. You kind of just want to say like please stop playing now, and doing that by setting a bool. And if you want like stuff that you would normally use a queue for, like that's what we would use input events for. If you just want to fire something off and say like, hey, now we are changing the map, then you would send a map change thing, and then other things can react to that. But for some of the stuff that we do a lot in the replayer, the mutex thing worked better for us. So it's a trade-off between what you want to do.
Yeah. How do you test this locally as a binary without the React part? Oh yeah, you mentioned that you can quickly run it up on your machine, right?
Yeah. So what we do is like the main part of our application is all in the library, and then you just add an extra binary where you add a few extra systems. Like you might add like some debug UI. You might add some hotkeys that you can go backwards and forwards and stuff, and then a bit of loader code to load the replay data outside of our platform. And it's not like I think it's like 50 lines of extra code, and then you just use the library to construct the Bevy app, and then you run it, and then it starts up on your computer. So you like it's very easy to I think we have currently 2 or 3 binaries that loads in different modes, but all of them are this short. So it's a very nice way to sort of have basically test scenes to run with.
Yeah. But those are all internal, right? That's not a product that someone like a user can download or whatever.
No, that's just part of our Rust workspace that you can stay cargo run, and then one of those binaries, and then it just loads the application.
Yeah. Was that ever like, this is a bit derailing now, but was that ever like a thing to that you investigated to potentially make it a downloadable thing?
It's a thing that I have been considering. Like, it would be really cool to have this as for example, an Android application that you could download, or as a program that you could download for Windows and stuff. But it's a bit hard because we also needed to interact with our platform. So if we find the right use case for it, that's definitely a bonus that that Bevy can also handle that case. But for now, it's not really a thing we've planned.
Yeah, I guess the network interaction happens from the Bevy from the React side then.
Yeah,
it would be a little bit hard then to
Yeah, we have a backend running, and we do GraphQL to speak to the backend, and basically React can take care of all of that, and then just give Bevy very simple like data, so we don't have to sort of put all of that inside the WebAssembly.
Yeah. So yeah, the last question, actually something I also was wondering. So you mentioned this event sending stuff, and the question is, does that mean that you do not use Winit since you're sending events manually? Like you mentioned input events?
No, so that's a good question. So we do use Winit, and actually because we are on this old Bevy version, I've had to like have my own fork of Winit where backport patches, because Winit has had a lot of bug fixes since our version. But the problem is that Winit sort of, especially back then, I think that might also actually have improved. So maybe that just works out of the box now. I'm not sure. But it doesn't really handle the canvas resizing thing specifically, which is why we needed the resize observer stuff. But the other events that we can sort of send from the outside are just basically like you click a button in the React UI and you want something to react to it in the Bevy app. Then for some use cases we use events for that. For some we use these shared mutex objects. It's depending on what is easier for each feature.
Okay.
Yeah, we do use Vinet.
Okay, so the clicking and the dragging and stuff, that when you mentioned touch events, that's still using the Vinet foundation.
Yeah.
Okay. Okay, interesting. Yeah, that's all in questions. Kristoffer, thank you so much, and chat, give a big hand to Kristoffer. And it's really cool to see like real world usage scenarios of Bevy, and this is at least game adjacent, right?
Yeah.
So thank you so much, Kristoffer, and yeah, hopefully see you at the Rust the next Rust conference as well.
Yeah, I think it's
Bye-bye.
Rust week. Yeah.
Oh yeah.
So.
Absolutely. I saw you said you would come, so
yeah.
That's going to be cool. Thanks, Kristoffer. So we are done for tonight, and I want to say a big thank you for everyone who joined. I'm getting more and more people reaching out for potential ideas for speakers, so I'm very grateful to get more of those. If you have anyone in mind that you think is maybe just too shy to reach out for themselves, give me a little nudge and I will reach out. And there's so many cool projects and initiatives going on in the community. I just want to make sure we get as much as possible from here to hear from people that are willing to share in such a format. So yeah, thanks for joining, and please make sure to stay up to date with the Meetup page or the YouTube channel, wherever you prefer. And like I said already in the beginning, the recordings will be coming up a little bit from now. And yeah, that's the 8th Bevy Meetup and the first one of 2025. Thank you so much for being here.